we're going to unravel the story behind one of the most elegant and, honestly, powerful rules in all of physics, Ampere's law. This whole thing starts with one brilliant mind in 19th century France and ends with the incredible technology that's literally powering our world as we speak.
So let's just dive right in. I mean, you've probably said the word amp 1,000 times, right? It's the basic unit for electric current. But have you ever actually stopped to think about who the amp was? I mean, there was a real person behind that name whose curiosity completely changed everything.
And that person was André-Marie Ampere. He was a French physicist and mathematician who was living right in the middle of this incredible scientific revolution. You gotta understand, he wasn't just some name you memorize for a test. He was a key player in one of the most exciting periods of discovery in all of human history.
And this timeline here, this shows you the exact moment things kicked into high gear. It's 1820, and news of a new discovery, one that connected electricity and magnetism, sent absolute shockwaves through the scientific world. For Ampere, this wasn't just some interesting fact. Nope, this was a call to action. In just 6 years, he published his masterpiece, and decades later, his name was immortalized as the word we all use for electric current. So what was this huge puzzle everyone was trying to solve? Well, scientists had just figured out that electricity could create magnetism, but they didn't know how. What was the exact relationship? Was there some kind of universal rule that governed this brand new, invisible force? That was the big question, and Ampere made it his mission to find the answer.
You see, Ampere's genius was that he didn't just want to watch what was happening. He had this core insight. These two forces, electricity and magnetism, they weren't just buddies. They were two sides of the exact same coin. So he set out to find the mathematical language, the perfect equation that could describe this deep connection. And guess what? He found it. The grand finale of all his work is what we now call Ampere circuit law. And it is an incredibly powerful and really a beautiful piece of physics. It just so elegantly connects the amount of electric current you have with the magnetic field it produces.
Okay, I know what you're thinking. That sounds like a total mouthful. Line integral, arbitrary closed loop, I get it. Those terms can seem pretty intimidating. But don't worry, just stick with me here. The real beauty of this law isn't hidden in some complex math. It's the incredibly simple idea at its heart. Let's break down what it really means. So let's just boil down that big, complex definition. Imagine a long, straight wire, and you've got electricity flowing through it. Ampere's law tells us that this current creates a magnetic field that just swirls in perfect circles around that wire. And here's the kicker. The more current you push through the wire, the stronger those magnetic swirls become. That's it. That's the core idea. And this is not just some abstract idea to think about. Oh no, it is an incredibly practical tool. Physicists and engineers use Ampere's law all the time to figure out the strength of magnetic fields. For the right kinds of problems, it gives them this amazing shortcut. So, how does it actually work? Well, it's pretty much a simple 3-step recipe. First, you just choose an imaginary path. Think of it like drawing an invisible lasso around your electrical wire. Second, you measure how much total current is passing through the inside of your lasso. And third, you plug that number into the formula, and boom, you've just calculated the magnetic field. It takes what could be a really hard problem and makes it way more manageable. And this is where you really see the genius of it. For problems that are nice and symmetrical, like a long straight wire or a coil, Ampere's law is like a lightning-fast express lane. Now, there's another law that can solve any problem, but it's way more complicated. Ampere basically gave us a perfect, elegant tool for the right job. So, why does a law that's 200 years old still matter so much? Well, because its impact is everywhere. Ampere's discovery isn't just locked away in some physics textbook, it is the invisible engine that drives so much of our modern world. Seriously, think about it. The little solenoid that kicks your car's engine into gear, that's using Ampere's law. The giant electromagnets that lift cars in scrapyards? Yep. The massive particle accelerators that smash atoms? You bet. And even the MRI machines in hospitals that save lives? They all rely on creating incredibly strong, perfectly controlled magnetic fields. And how do we calculate those fields? With this very law. None of this would be possible without Ampere's work. And just to really let the scale of this sink in, look at this number. A typical MRI machine creates a magnetic field that is 30,000 times stronger than the entire magnetic field of planet Earth. That is a staggering amount of force that we've learned to harness. And we can do it because André-Marie Ampere, 2 centuries ago, figured out the rulebook. So there you have it. From one man's intense curiosity to a physical law that powers our entire world. That is the story behind the amp.
Ampere showed us all that two forces that seemed totally separate were actually deeply, fundamentally connected. And it really makes you wonder, doesn't it? What other incredible connections are out there, all around us, just waiting for the next curious mind to find them?